decided we could make something better. So I got together a team of our process engineers, our PhD chemists, and we decided, let's develop product that is better than anything anybody has got. And we did it specifically to target the high performance marketplace.
And to us, it was very, very imperative to have it tested on a dynamometer, to be able to actually prove what the product does.
EFS Combust is designed specifically to make engines run cooler, runs better, economize on the fuel, lower operating temperatures. At the end of the day, a win-win-win for everyone.
We had to select a facility that we thought was as credible as it gets in the industry, and that's why we are here doing this testing at Phoenix Performance.
We are a performance car tuner located here in southeastern Pennsylvania, about 40 miles west of Philadelphia. When it all boils down to the bottom, what we really want to do is develop a solution for people who want to take cars out on track and get the maximum.
We have disruptive technology. We're going to change the way we use fuel. We're going to change the way fuel is combusted in an everyday car. We're going to turn regular fuel into great fuel. 87 octane plus EFS Combust creates a dynamic environment to turn a regular everyday car into just an unbelievable performance machine.
Well, that's a very interesting claim, a very aggressive claim, so let's get started with the testing process. We have a DynoJet, one of the best research and development machines you could possibly get.
A chassis dyno is used for measuring the car's horsepower at the wheels. It calculates the speed that the wheels are turning combined with the RPM signal that it picks up. I was surprised at what it did.
There are many things that they say, throw it in the tank and it should work great. And it doesn't when you put it on a dyno and you go, oh, then what's the point? Here, we put it on a dyno, we see real results. And you say to yourself, okay, let's go, and yeah, preliminarily, it looks really good.
You know, we put 87 octane, it felt like it was putting 100 octane race fuel in the car. It seemed to rev higher. You know, it felt like it spooled up quicker. I mean, it honestly did, and you could see the gains in the middle. I mean, what I was feeling came out in the numbers. It really, that mid-range, it really just seemed to rev up quicker. It had this, it kind of was like it was in an extra gear.
We saw a reduction in EGTs. We saw a reduction in stabilization for the operating temperature of the engine, which is very important. And if you look at any good engine builder today, you ask them what it costs to get 5% increase in torque. How do you value this? We're talking about tens of thousands of dollars to do this. You put 1 ounce of EFS Combust, 15 gallons of gasoline, you get approximately 5% increase in torque. That's unheard of in the performance industry. It doesn't exist, and we're really excited about that. And to do it and still reduce emissions is even much more better for the environment. We did it in theory. Now this is a qualified mechanical test process to validate our technology.
It's satisfying and rewarding for everybody involved when you can see a real change. And while 2 or 3 horsepower is still a real change, when you look at this with 15 foot-pounds of torque and probably about 10 horsepower in that mid-range, that's a real change that you can be excited about.